Okay, we're going to talk about the reversible reaction. It is a special kind of reaction. In this reaction, what happens? Actually, it is a combination of decomposition and combination. That was the synthesis. Okay, so you can see over here. Just take this example here. The combination is happening. Again, it is decomposing. So both reaction together. So reversible reaction is what? A direct combination plus decomposition. Both happens at a regular interval of time. So what is happening in this case? CuSO4 5H2, that is a blue withdrawal we call, copper sulfide having the 5 molecule of water with it. So it turns to be blue color. Okay, blue color. When we heat it up, then what will happen? It will turn into CuSO4 and H2O will evaporate. It will evaporate. When you're gonna heat it up or you keep it in the presence of desiccator, which absorbs the moisture like H2O or NaCl, these kind of thing, you will keep it up. Keep it with that thing, then it will take out the water molecule from the CaSO4 and it will turn into kind of brown or gray we can say, gray color or the dark color it will turns into. So what is happening in CuSO4 when we are heating it up? It was turning it CuSO4, which was a gray color, blue into gray. But one thing here is it is giving the book in the chemical reaction. It is not a chemical reaction. It is a physical reaction. Because there is no chemical composition is changing. So you will say where the H2O has gone, sir, the chemical composition has been changed. No, obviously not. What happens? Again, you give the water to it, it will again change into the same form. So what is happening? When you're taking out water, it was dissociating in this way. And again, when you are adding up the water, again, it is forming in this way. So this reaction simply a reversible reaction. Means a reaction can go this side. From decomposition, what is happening here? Decomposition is happening. And what is happening here is combination or synthesis is happening. Getting the idea? So reversible reaction is actually when the decomposition and synthesis both happen at the same time with the same elements. Okay, means we don't need to add the extra element over here. So that's basically a decomposition reaction is. So when the copper sulfate decomposes, they form the copper sulfate, which is basically having the 5 molecules of water. Okay, penta water molecule it is having, it will dissociate, it will form copper sulfate plus water in this case. So what will happen? Again, when you give the water to CaSO4, when it comes to the contact of the water CaSO4, it will again transform into CuSO4 5H2 and again the color will turn into blue. So means the physical, it is not actually a chemical reaction, it is a basically physical reaction. Means we can bring back easily by just doing the reversing the same process and it will bring back into the original form. Okay, it is not a chemical. Why? Because it is having the same property as it is having. Same kind of property both they are having, even though it is having 5H2O, but the property will remain same. Chemical property, the chemical composition remains same. That's why it is a physical change. Okay, so sometimes a very good example is there where the chemicals are basically involved and it is changing, but it's not a chemical change, it is a physical change. So you need to remember this one, a very nice example. Next example, see over here, it is a chemical change. Why? Because when you apply heat, N2O4, it will turn into nitrogen dioxide. When you apply heat, and as soon as you just keep on applying heat, it will stay in the same chemical composition. Now the chemical composition is changing over here. When we cool down this, again, don't give this sign, okay? No need to give the sign. I've just given the sign to make you understand, but don't give the sign while writing the reversible reaction. NO2, when we apply heat, Na2O4, it was changing into that. But when we cooling down this one, again it will transform into that. Means element A is changing into B and again going back to the A. Now you can see this is the reversible reaction. And whenever a reversible reaction happens because of the heat we apply, then the reaction we call it thermal dissociation. Okay, whatever. The thermal dissociation. So what is happening? It is a reversible reaction. A reversible reaction when we can turn into different chemical and again bringing back the into the same chemical by just reversing the physical process that we are applying, either heat or either electricity or the pressure. Okay, anything else by using certain kind of other element also which is not taking the participation in the chemical reaction. Okay, so means we can revert the reaction, direction of the reaction. A product was there, reactant was there producing different product, and the same product react again and produce the same reactant in this case. Okay, so means what? A reactant, it is this A is producing B and then B again producing A. So idea is basically clear. Okay. So whenever there is a reversible reaction happens because of the heat we apply, then the reaction will be thermal dissociation. Always remember this one. Take a very nice example, which is very nice example of heat we have given. Take the example of pressure. Okay. When you apply the pressure, N2 and H2, they combine together, they form the ammonia. Okay. But when you release the pressure, again ammonia will dissociate and form N2 and H2 separately. So this is basically a reversible reaction. We are applying a physical thing over here. The pressure is, but the chemical composition is changing. Okay, that means it is a chemical reaction. But what kind of chemical reaction? It is a reversible reaction. So whenever the reversible reaction is happening, we can give this example. But whenever the chemical reversible reaction is happening, we cannot give the example. So if I'll ask you which one is the physical reversible reaction from these two options, so we will take this out. Or if I'll ask which one is the chemical reversible reaction, so we will take this one, but this not, because it is a physical reaction. Because it was just the form was changing, but not the chemical composition. Here you can see new chemicals is forming. So that means it is a reversible reaction. Hope the idea is clear. Let's proceed to understand the different types of chemical reaction. So we have understood the two chemical reaction, the direct combination of the synthesis reaction and decomposition reaction. And the part of the decomposition reaction, we also get the idea. Now we have two more decomposition reaction we will study in the next show. Thank you so much.